Welcome to this introduction of the redesigned Build Earth model for version 4 of 3D UTAP Wells and the Compositional Palette. UTAP Wells is a well log modeling software application that enables one to perform well log simulations using physical and petrophysical properties. To accomplish creating a model, the software uses a number of components in the window called Build Earth Model. The Build Earth model consists of 6 modules listed here: Compositional Palette, Petrophysical Calculator, Detect Boundaries, Populate Properties, Geometry Along Well, Geometry Full 3D. This is a series of videos which present the modules and what they do in more detail. We also have a video demonstrating how to create a simple Earth model. It is an Earth model with 5 layers and 2 radial zones. Layers 1 and 5 are pure shell. Layers 2, 3, and 4 are clean matrix with different water saturations and with gas, oil, and water as fluids respectively. The Build Earth model is opened by clicking on any one of these 6 icons in the Well interpreter. Clicking on the palette icon will open the Compositional Palette. The palette consists of 8 panels. Both the Thomas-Stieber diagram and the Common Petrophysical Properties panels will be presented in separate videos. Here the focus will be on the compositional, property, and volumetric panels. In the matrix composition, clicking on the down arrow shows that there are a number of predefined compositions that can be used to populate a layer in the well model. It is also possible to create custom matrix compositions. Using the Add Component button, a variety of components may be added. Using this arrow, a mineral from the drop-down list may also be chosen by clicking on it. The composition needs to be normalized to equal 1, which may be done by clicking the Normalize button. This will give each component 20% of the total mix. If a change in one component occurs, click on the Normalize button and the program will redistribute the numbers. For example, if 0.5 is removed from this component, clicking on the Normalize will reallocate the percentage for each component as seen here. The new composition can be named and saved, thus enabling it to be used in a different layer of the model. The shell composition panel works in a similar manner as the matrix. There are various clays within the component list for the shell composition. In addition to adding solid components, a fluid or fluids may be added to the composition. All components also need to be normalized. The salinity concentration of the shell can be modified using the up or down arrows or by typing in a value. The blue panel below is where property values in both the petrophysical and property layers may be modified. A property value such as salinity may be found to vary within a petrophysical layer. This blue panel in the upper right, a rectangular bar, represents the specific petrophysical layer of a model, and it may be divided further if there are property boundaries and/or radial zones in the layer. For example, in layer 4, it has 3 property layers, 5, 6, and 7, plus radial zones 1 and 2 for each property layer. The top layer in radial zone 1, shown here as property layer 5, has a value of 40,000 parts per million saline. Layers 6 and 7 have 42,500 and 45,000 parts per million respectively. Therefore, different property conditions may be composed within a petrophysical layer. Using these pull-down menus of the property layer and radial zone, one can move to a specific layer or zone respectively. Moving between the property or radial zones may also be accomplished using these arrows, which moves through one layer or zone at a time. The properties specified in this area can apply to the entire property layer or even the entire petrophysical layer, depending on which one of these boxes are checked. If the settings apply to the entire property layer, then the property layer is highlighted, as seen here, both zones 1 and 2. If settings apply to the entire petrophysical layer is checked, all layers are highlighted within this petrophysical layer. The next panel for presentation is the volumetric reference. The volumetric reference is a graphic representation of multiple aspects of the petrophysical layer. This is an interactive panel which allows the changing of parameters within the petrophysical layer. For example, changing the porosity value from 0.25 to 0.4 keeps the 25% amount of the water saturation. Any of the values associated with the volumetric reference may be modified here. Changing the different values may also be done at each perspective window, either using the up or down arrows or by typing a value. As expected, the increasing or decreasing of a value will also change the volumetric reference graphic. The volumetric reference panel gives the ability to quickly and interactively change multiple values within a petrophysical layer. The panel below the volumetric reference is a new feature in version 4. In the petrophysical layer window, the user quickly move from one layer to another. For example, to move from shale layer 1 to layer 4, clicking on the small down arrow displays the layers, and by choosing number 4, it moves directly to layer 4. Throughout UTAP Wells, there are tool tips or informational items when a mouse is placed over an item. Both of the buttons have tool tips. The Save and EM button tooltip. Save palette values in the Earth model, only in the currently selected petrophysical layer. The multiple button tip is Save palette values in multiple Earth models petrophysical layer. If the settings apply to the entire petrophysical layer, must be checked in the blue area for the change to occur. A simple example would be to change the salinity in layer 2 to 75,000 parts per million, and then want this change in both petrophysical layers 3 and 4. Check the settings apply to the entire petrophysical layer box. Then using the multiple button, add checks to layers 3 and 4 and click Save. Now all layers have the same salinity value of 75,000 parts per million. The checkbox between the Save to EM and multiple, when checked, means that if a value is changed in a petrophysical layer, when moving to another layer, the change will be saved in the layer from which you are moving from. One last item to mention in the view. To demonstrate changing between the total and non-shale porosity views, the rock structure will be changed to laminar with shale porosity and shale concentration added. When toggling back and forth between total and non-shale, it is observed that total porosity and water saturation values and their designations change, as seen here. This panel also has checkboxes for EMT and NMR options. They will be presented in another video. This is the end of the video, introducing you to several tools, modules, and additions in the Compositional Palette. Thank you for your time.